Electric Cell and EMF. Objective: to study about the working of a battery and its EMF. Ohm's law tells us the relationship between the resistance of a conductor and the potential difference across it. But how do we create potential difference across a resistor? Potential difference is created in electric circuits using a device called electric cell. A single cell or a collection of cells can combinedly be called a battery. Battery is a device that stores electrical energy in the form of chemical energy and converts that energy into electricity whenever connected in an electrical circuit. Generally, any battery has three main components: the anode, the cathode, and the electrolyte, in which chemical reaction occurs. Working of a battery can be understood as two processes occurring simultaneously. When the battery is connected in a circuit, oxidation and reduction reactions occur inside the battery, because of which positive ions start getting accumulated on the cathode, while negatively charged electrons accumulate on the anode. This charge distribution creates an electric potential difference between the cathode and anode, cathode being at higher potential compared to anode. Because of potential difference, the extra electrons at the negative terminal start moving to the positive terminal, trying to make the cathode neutral. This cycle of accumulation of charge and redistribution of charge through the external circuit occurs continuously, ensuring a constant charge flow in the circuit. Charge carriers experience resistance when they pass across a resistor. This is the reason why we need battery to push the charge continuously in the circuit. For convenience, we can replace the electron flow with equivalent positive charge flow in the opposite direction. Direction of positive charge flow is considered as the direction of current. Battery does the same work on the charge. Battery brings charge carriers from lower potential to higher potential, thereby increasing the electric potential energy of the charge carriers. The work done by the battery per unit charge in moving it from low potential terminal to high potential terminal is called electromotive force or EMF of the battery. The name electromotive force is somewhat misleading, as it is not a force. It is work done per unit charge and has the same units as the electric potential, volts. Summary: work done by the battery per unit charge in moving it from low potential terminal to high potential terminal is called electromotive force or EMF of the battery. SI unit of EMF is volt.
Electrical charges generate a field around them. These fields of force repel and attract other electrically charged particles. Like charges repel and opposite charges attract. When enough of these charged particles are separated, a potential difference is created. Electromotive force is a potential difference measured in volts. The symbols commonly used for electromotive force are E or V. The potential difference in charges is what forces electric current to flow. There are 7 fundamental forms of electricity generation. All of these forms of electricity generation create an electromotive force or EMF. One of the most commonly used forms of electricity generation is the electrochemical reaction, or better known as a battery. The potential difference across two open terminals is known as the unloaded voltage. The electrical potential difference forces current flow when a circuit is attached to the source of EMF. There is typically some amount of resistance in all electrical components and devices. When current flows, the voltage across the terminals of the source of EMF is no longer the unloaded voltage value. There will be a voltage drop inside the device due to the internal resistance of the EMF source. When the circuit was not connected, the battery had an unloaded voltage rating of 1.5 volts. Once the circuit was connected and current started to flow, there was a voltage drop across the internal resistance of the device, and the applied circuit voltage was reduced to 1.3 volts. The DC power supply is a commonly used device in the lab. This device has the ability to create different amounts of electromotive force. As the voltage is increased, the potential difference between the terminals is increased. Note that the unloaded voltage of the power supply is set to 5 volts. A DC power supply will experience a loss of potential difference due to the internal resistance of the supply. When the circuit is connected and current starts to flow, the internal resistance of the power supply reduces the applied circuit voltage to 4.7 volts. Electromotive force is the potential difference that forces current to flow in a circuit. We have looked at a couple of different sources of EMF and at some practical applications.